A very good morning, my dear students. So, in this Unit 7, now we are going to discuss the topic thermodynamics. The term thermodynamics means flow of heat. It is derived from the Greek thermos means heat and dynamics flow. In our daily life, we come across many useful reactions such as burning of fuel to produce heat energy, then flow of electrons through the circuit to produce electrical energy, and then metabolic reaction to produce the necessary energy for biological functions, and so on. So, thermodynamics, the study of transformation of energy, it explains all such processes quantitatively and allows us to make useful prediction. So, now we are going to see the first question in thermodynamics. State the first law of thermodynamics. It is nothing but laws of conservation energy. The first law of thermodynamics tells us that energy can be changed from one form to another, but can be neither created nor destroyed in any process. So, how can we say in mathematical expression del E equal to Q minus W? Del E means internal energy, Q quantity of heat, minus W work is done by the system. For example, if you want to prepare any hot water from cold water, the cold water have to take in a glass bottle and it has to be kept on the hot plate. After some time, the heat energy is transformed from hot plate to cold water. Now, the hot water is prepared, but the initial temperature is reduced on the hot plate because heat is transformed from the hot plate. So, internal energy del E is present in the hot plate, Q. So, quantity of heat is transformed to the cold water in a glass. So, minus W work is done by the system. Question number 2. What are the limitations of first law of thermodynamics? What are the limitations of first law of thermodynamics? It is independent of atomic and molecular structure and reaction mechanism. So, the thermodynamics it denotes only the flow of heat. It does not say about the atomic and molecular structure and shape of orbital. This kind of study is not explained by thermodynamics. So, what are the reaction takes place? That and all, it is not explained. It is independent. Point number 2. The laws can be used to predict whether the particular reaction is feasible or not under given a set of condition. In which temperature, in which pressure and which volume the reaction will be entered. This kind of things will not predict in the thermodynamics. It is second limitation. Point number 3. They cannot give the rate. Rate is nothing but speed at which the reaction takes place. Right? So, speed of the reaction it is not explained by thermodynamics. In other words, thermodynamics deals with the equilibrium condition quantitatively, but does not take in account the kinetic approach to the equilibrium state. So, kinetic study and all we cannot study in the thermodynamic. So these are the points come under limitations of thermodynamics. So before studying the laws of thermodynamics and their applications, it is important to understand the meaning of new terms used frequently in thermodynamics. So what are the terms? The first one, what is system? What is system? Just look at the picture. System it is drawn with outline, that is boundary, is out of the system surrounding. The system and the surrounding are in universe. Okay. The system is a part of universe which is under thermodynamic consideration. It is separated from rest of the universe by real or imaginary boundaries. Where you are going to study the thermodynamics, that is called system. It is called system. The outline of the system is called boundary. The system is present in the surrounding. The system and the surrounding are in universe, right? Here we have two types: homogeneous system, heterogeneous system. Homogeneous mean same, heterogeneous different. So which one is same, which one is different? If the physical state of all its constituents are the same. For example, mixture of gases. Gas mixed with another gas, it gives only one state. That's only one physical state. We cannot identify after mixing. So homogeneous. So one more example, completely miscible mixture of liquids. So milk in water, water in milk, completely miscible. We are unable to identify. That is called a homogeneous system. Heterogeneous, it is opposite of homogeneous. If the physical state of all its constituents is not the same. So good example, oil in water. After mixing, we can find the oil is floating on the water. Next. So which statements we can give for surrounding? So everything in the universe that is not part of the system is called surrounding. Everything in the universe that is not the part of the system is called surrounding. Then boundary. The last slide I said is outline of the system. So anything which separates the system from its surrounding. Anything which separates the system from its surrounding is called boundary. Okay. Next we are going to see the types of system. Open system, closed system, isolated system. It's nothing but a glass of hot water. The first one, no lid is on the glass, so that is open. But the water condition is hot, right? Second one, just you keep one lid on the glass of hot water. Third one, isolated. Isolated is nothing but thermo flask. In the thermo flask, you have to take a hot water. Now, what is a condition? Open system, now we will see. The system which can exchange both the matter and energy with its surrounding. It is called open system. A glass of hot water you have to take, but no lid on the glass. So what will happen? The energy, heat energy will be going out, and matter is nothing but hot water. So day by day gradually decreasing. So both will exchange, both will go to the surrounding. So both matter and energy with its surrounding. That is called an open system. So hot water contains in an open beaker is an example for the open system. So in this system, both water, both matter, water vapor, so matter is nothing but water vapor, and energy, that is a heat energy, is transformed to the surrounding. Closed system. The same hot water, and you should put lid on the beaker. So what will happen? A system which can exchange only energy but not matter with its surrounding is called a closed system. Heat energy alone will escape to the surrounding, but matter, the hot water, does not go out. Here the boundary is sealed but not insulated. Hot water contained in a closed beaker is an example for a closed system. So in this system, energy, heat energy, is transformed to the surrounding, but no matter, water vapor, can escape from this system. So one more example, a gas contained in a cylinder fitted with a piston constitutes a closed system. Next, the third type, isolated system. Isolated system. A system which can exchange neither matter nor energy with its surrounding is called an isolated system. Here the boundary is sealed and insulated. So example, hot water contained in a thermos flask is an example for isolated system. So in this isolated system, both energy, heat energy, and matter, is nothing but water vapor, neither enter nor leave the system. So both heat energy and matter does not exchange to the surrounding. It's an isolated system. Thank you.